Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. Happy birthday to CoreOS. It's their second birthday, and they are the sponsor for this episode of the New Stack Analysts. And they have had quite a run over the past 2 years. They're a major player in the container ecosystem. You should check them out at CoreOS.com. Happy birthday, CoreOS. Now let's get to the show.
Hi, Alex Williams of the New Stack, here for the New Stack Analyst Show at GopherCon with Alex Polvi, CEO and founder of CoreOS, and Mitchell Hashimoto, CEO and founder of Hashicorp. We're here at GopherCon, and I'm just trying to get like a take on maybe how you're seeing the Go programming language evolve. What are some of the things that you're starting to really notice, and maybe even things that are different than what were present here, a year ago? Maybe Mitchell, you can start. I know you may have to take off a little early.
Sure. I think I would have said very similar things last year, but it's like really solidified this year, which is just that there's no future without Go at this point. There's like way too much invested in it, and like from a time and like energy perspective, and so many companies that I think the attendance also shows that. It was, last year there was like 350-ish, and this year there's over 1,000. So I think in terms of the community, I'm seeing that, and as a result of the growth, there's still a very technical conference, but we're seeing a lot more talk about community and working together and things like that, like experiencing that growing pains as the community gets that large. So it's a major thing.
Yeah, I mean, when you first asked us, my initial thought was, it's gotten popular enough that people don't like it, but that's good. No.
Yeah.
Go haters weren't around last year.
Yeah.
But that happens to anything that gets popular.
Totally.
No, I don't know, I love this little community and the whole, I mean, Go is not just it's like a programming language, but it's also like a way of doing software development as well.
What is that way?
What is that way? That's a good question. Pragmatic, yeah.
I heard that, painfully pragmatic.
That's I like to say.
What does that mean?
The way I like to say that, because it's like, Go, to someone who's like a programming language enthusiast, Go is like from the Stone Ages, basically. Like it takes into account like what more modern languages have done, but it doesn't like do anything fancy. It's basically like a nicer C, and so like to them it's just like disgusting and terrible.
It's like Atari almost or something.
Yeah, it's just like they look at it and they're like, how could you write in that thing? But then I like the base programming languages. Like, are people creating value with it? And like, there's so many companies and so many things coming so fast. So it's like, it's clearly good just because there's so much value coming out of it. And so for those people, it's just like painful because it's like, it's like so bad. But they view it as so bad, but we think it's so good.
Yeah, it's very precise, I guess. Like, it defines just a way of how to write software, kind of in the as a natural result of the language itself. And then the other things like testing and benchmarking and all this stuff, if you kind of follow along with even the way you format code, there are programs to help you do that. Like, it's like, for us, it is the development like philosophy. We just follow the guidelines that the language gives you, and there's no debating about like how software should be built then. And so the only thing we have to worry about is actually building whatever software we need to go and build. So kind of like the full package. Other things like Java or C or whatever, there's flexibility, which is great, but it's also, the flexibility is where you introduce complexity and you introduce these crazy bugs and you introduce security issues and all of these things. And so Go is just very precise and gives you the like tools on how to program. So all you think about is writing your program and nothing else, which is surprisingly not the way most other languages
Isn't
are.
that how we're starting to see adoption too? Because if you're going to use any of these kind of if you're going to be in the container ecosystem and like contributing to Docker or Go or whatever it might be, you are working in the Go programming language.
Yeah, I would generalize that to just infrastructure in general right now. it's a lot of Go everywhere.
So, Alex, CoreOS is 2 years old. Is his second birthday this week. Tell me about your decision to use Go when you guys were developing the ideas for the company. Were you familiar with Go? What was your experiences with it?
Sure.
And why did you? And what? And I'm curious about the decisions you made to choose Go, and what were some of the trade-offs that came with that.
Sure. So Go is CoreOS's only language when we are developing something new. You have to use JavaScript and you have to use C, as a result of just the way certain things are built. But Go is the one we use for general purpose for everything. And the nice thing about it, we did that very purposefully. One, there's some optimizations you get from having just one team way of doing stuff. Everybody just knows how to work together, and there's no debates over silly things that aren't related to writing software, like how do you build it and how do you do the dependencies and all these things. We can just sort of have one convention, and that one convention gives us some tailwind that allows us to go faster. And I think that's why we've been able to ship so many different projects so quickly, is because Go just essentially solves that area. It's okay, we're doing everything in Go, and some of our programmers sometimes aren't thrilled with that, but I think everybody gets the organizational efficiencies of all being on one thing, and then occasionally you have to dip into JavaScript and C and stuff. But you just have to do that for working on the kernel or building a web page requires JavaScript, that kind of stuff.
So what were some of the thinking? Were there any? I'm curious about the thinking you went through, thinking about what are the trade-offs that we're going to have to make.
Sure. I mean, the nice thing about Go is there aren't really a lot of trade-offs. It's easy to use as a language, so easy to pick up and learn. It has it's fast. It's a compiled statically typed language, which is means it's a proper programming language. The dynamically typed languages like Python and Ruby are just a little bit more flexible and difficult to maintain at scale. So you have a proper programming language, it's easy to use, and then the concurrency primitives within Go just unlock kind of new applications altogether. I don't think etcd would be done well, really, in any other language. I mean, that's arguable, but Go just is perfect setup for these applications that require high concurrency and sort of all these different types of I/O happening in parallel, and it's just perfect for that. So I think Go enables a lot of this new technology that's happening too, because of the easy use, but it's a real programming language. It's fast. You're not going to have to rewrite it later to optimize it, that kind of thing.
So Mitchell, I think about that. I think about what you said when you said, infrastructure, right? And this whole community that we're seeing, emerge. For instance, just companies that are trying to figure out how to use, containers in different parts of the stack. So, is it Go that's helping drive the innovation?
Yeah, I think it certainly helps. Just because, like Alex said, you can build stuff really fast, and the stuff that's being built really fast is high quality, and because it's statically typed versus dynamically typed, it's a whole class of problems sort of disappear. So there's a lot less instability just from that just being gone, completely gone, type errors and things like that used to crash a server just can't happen anymore. So I think and deployment's a lot easier because they're static binary. So I think there's all these properties that just help make it so that things written in Go for infrastructure could just be iterated on very quickly and safely. And it also gives consumers of that software a lot more confidence and ease of just trying things out.
How does it give that confidence?
Confidence just because of the safety, the testing, the ideology of the Go community is very test heavy, and there's this single formatting style, so it's very easy to approach and view what it looks like if you want to see it. So I think there's a lot of safety there, and then it's just easy to deploy. It's always a static binary mostly.
So what do you think of of this conference, Alex, so far? Who are the people you're talking to? Who that you're starting to see here that you thought you see, or you wouldn't, or you weren't expecting?
All the companies that are showing up. It's funny. I mean, anyone you talk to, you're like, well, you must be using Go in some way, but I didn't necessarily expect that. So, I mean, if you look at the audience here, it's there's there's the kind of the startup Silicon Valley crew, but there's also just meaningful big companies out there that are hacking away on Go now and using it. I mean, it's just a new programming language to be meaningfully adopted is like not a non-trivial feat. Lots of things are picked up kind of in hobbyist level, but to start like organizationally be able to use it, and so I've been impressed by the breadth of folks here that are using Go in various ways.
So what do you guys take of what Russ was talking about this morning with like the need for this code of conduct in the community? He was talking about it in relation to how the open source community can sometimes be a bit obtuse maybe or blunt.
Yeah, I think the unfortunate thing is I think that I like to. I think that for the most part, like the majority of just people in general are just really nice and want to be nice, and it's just the few like not so nice ones that ruin it for everybody else. And the code of conduct is just a protection against that, which is like the organizers saying that they don't think that's acceptable, and also like a clear line, which is as a member entering that community, they know like if there what is unacceptable, and if there was unacceptable behavior, like what would happen, and it just makes them feel better about things. But I mean, from our standpoint of running open source projects for like 6 years now, there's been very few bad incidents. Like I could count on probably one hand, but the problem is like they're usually really like they affect a lot of people. Like it's this one person just causing a ton of problems, and so you just got to have to deal with that. And it's frustrating because there's so many good people, and so I think code of conduct, and for a long time before code of conducts were like having one was more popular, you just didn't, and you would deal with it just because you want to be nice. But it's nicer to just be explicit about what you're going to do.
I have no real comment on that stuff. I mean, it's unfortunate, like that even has to happen. But it is real.
That even has to be stated.
But it needs to be done, and everyone deserves respect, right? So there has to be something in place.
Well, I guess what's interesting to me about it is it speaks to what Russ was saying about how there's going to be this real need to have this open, inclusive community if the programming language is expected to continue to grow, right? But I don't think there's any difference between any other programming languages for that matter.
No. Community-wise, no. I think it's very broad. Like the need for something like that's very broad in general.
Yeah, I think these are just issues of getting a bunch of people together.
Yeah, I mean, I think it was you. I might have said this too, but it's like open source is very interesting because as it gets bigger, it just becomes its own little. I view it as its own little state. Like it has its own people, and there's certain people that are more influential for various reasons, like they contribute more, they're committers or something, and then there's rules for how features land and like all this stuff, and it's interesting to see because like you have to run this little microcosm within a bigger government, basically.
There's like, literally governance documents.
They're literally called governance, and so like you just have this thing, and sort of with any government, there's always going to be laws being broken, basically, and causing disruption in the thing. It's like, I guess for us, there's in general society, like. How often is it that someone actually gets like physically harmed? It's pretty rare. Like I don't think anybody on a day-to-day basis is like scared. Like I think today's the day I get physically harmed, except like unless you're being stalked or something crazy. But like in the community, it's the same way. But there's always like the tiny amount that do, and that scares a lot of people. So I think it's mostly about like protecting that. It's like just because like physical harm is rare in society compared to the amount of people you have, you can't just not have a law for it and be like, we'll handle it on a case-by-case basis. You still need some like explicit thing, which is like, this is what we're going to do if this happens, and you can't do this, by the way.
So maybe we should just spend a little time, each of you guys explaining what your company does. I'm sure there's people out there who may be new to who you are and such. So maybe Mitch, you could describe a little bit about what you guys do.
Sure. So Hashicorp builds tools to help you deploy applications and manage infrastructure sort of end-to-end on any cloud platform, VMs, containers. We're trying to just help organizations deploy faster, deploy more safely using technologies they're comfortable with, as well as looking forward to technologies that are sort of more cutting edge.
And at CoreOS, we're building the software to help companies run infrastructure in this way that we've seen that really big companies do. We call it, Google's infrastructure for everyone else because there really isn't a good name around it yet. But it's a combination of containers and distributed systems and standard hardware, and the ability of a company to be able to add more servers to get more capacity, to think about their applications as their first class objects as they do the deployment and so on. And all the open source projects that we've been building are to help enable kind of the general ecosystem to run infrastructure in this way. And then on our products, we build that platform in a box for companies that don't want to assemble it all themselves. So we're really focused on enabling this kind of new way of running infrastructure, again, that we've seen the hyperscale guys do, Google, Facebook, and so on, but making it applicable to all companies. And the benefits of that style of infrastructure just in general are things like higher utilization, better availability of your applications, faster to deploy and more easily update your applications running on that, and so on, which are pretty big concepts for these companies that aren't as sophisticated as the web scale guys.
Do you agree with that? Google for everyone?
Yep. Well, I think it's yeah. And
what's the category? There is no name for it, actually.
Yeah, there's no name for it.
Containers kind of got it, but
yeah, I mean, I think it's always like
container ecosystem seems to be like the holder for.
Yeah, but it involves the distributed system side too. But all the container folks are doing the distributed system stuff too, so it's kind of goes hand in hand.
Yeah, I mean, it's Google for everyone in the sense that like when you work at that scale, you have like every base point is like so expensive that you have to optimize everything. So they find a way to get the highest density possible and with effort that no one else is going to give. But that trickles backwards in terms of like that's the future. Like we should all get that density. So I think like even though they had that like a decade ago, now it's coming into more like commercial, more general in the industry. And so I think that'll continue to happen. Like we're CoreOS, like we're helping like push people towards that. But then there's going to be the next one. Like it's going to keep happening over and over again, which is like we got this and we think it's really good, but there's probably something a lot better that someone who it really matters for is working on, but doesn't broadly apply to everyone else yet because we're so far behind.
So it's just that gap, that it's that gap that is driving, a lot of what we're seeing.
Yeah, I mean, it's a decent change for companies and their infrastructure to get to this model, but once we're there, you have some big benefits around, for instance, being able to change your infrastructure again much more easily. Right now it's very hard to cause change in infrastructure, but once we kind of cross this hurdle, you should see rapid kind of innovation because your infrastructure becomes much more like safe to manage. Right now, state of the art is like get it running and don't touch it because everyone's so scared of how
only these two people can touch it.
Right, exactly. And definitely not during Christmas or whatever, right? And that's not how the big company, these big guys are able to manage their infrastructure. They're able to like shut down a whole data center and like with power plug get ripped out and it's okay, and that type of stuff. And that's how everybody should be able to run their infrastructure. They just don't because it's too difficult today. Like you just can't do that easily. So companies don't do it. And we want to help all companies do that. And we think that,
for years we've heard, I've been covering the enterprise world for, several years now, and for years you hear these stories, always these stories about how companies are still heavily invested in, in legacy infrastructure, and and they have these legacy applications, and they're not going to change. But we are starting to see that change.
Yeah.
And I'm always trying to understand why. Why now? And what in that respect, then, well, let's just start with that. Why now?
What is the event essentially that's triggering this?
An event, or what is the
compelling?
Yeah, the compelling factors. I mean, in some respects, I can date it back to like I say circa 2006, 2007, when you started to see companies like Twitter emerge, right? And how they just basically opened up everything, so developers could just plug API, create new services out of those APIs.
I think there's two things. I think there's two things going on. I'd love your opinion on this too. But the first is for all our software only is good for companies that are writing software in some form, which seems obvious, but think about it. Like, so the company has to be building software internally. Not all companies build software internally, but there are definitely a lot more doing that now than there used to be. So I think that's one big compelling event. Think of just like mobile. Like pretty much every company has a mobile app, and banks now have all their web interfaces for managing stuff and so on. So everybody has to be a software development company. And the other edge of it is the internet is like factually being fully utilized by the world in a big way, and that's just it didn't happen overnight. No. It's been a gradual grind, but it is plumbing of the world now, and that general growth of the internet I think is driving a lot of this. And only the hyperscale guys had the problems that warranted this, and now more companies have the problems just because the market of the internet is bigger than it ever has been before. But I don't know. Why do you think all this change is happening right now?
I think all this change is happening right now because there's I don't think it's just containers. I think cloud is actually a big reason for it, and I think that cloud and containers kind of go together really well. But I think that was the big thing where there is basically I think it requires a 10x or a high multiplier improvement to push people to the next thing, and there's that opportunity with cloud things, which is get rid of a lot of your capital expenditures and move it to operational costs, and don't own physical property that has to have servers anymore and things like that, and I think that's a big motivating factor. I mean, I'm still seeing a lot of people that there's still a lot of legacy that people don't want to touch, but I think that's always going to be the case. I think the vast majority still is we'd like to move this forward. And I think another part of it is a lot of companies have felt the pain of not doing that. We've talked with some companies that are still working to switch to virtualization, and their biggest fear is we're almost at the finish line of this virtualization thing, and we don't want to do this again. We don't want this to take another decade. We need this to be easier. And so, yeah.
So they want to. So they just want to live with what they have.
No. So I'm saying they're more eager to move to the next thing so that they're not late to the game. So they're not. It doesn't take them another decade to get there. They're not realizing cost savings as fast as everyone else, and it's hurting them. So I think people are more aware now. It's more documented, by big companies too, of how having better infrastructure saves costs almost everywhere else. Development speed, people buying products just because your page loads faster. Kind of across the board, there's all sorts of savings, big and small, you could get. And so I think it's more accepted that when the infrastructure team is we need to switch to this new thing, the CIO is more open to that.
Well, great, Mitchell. I know you have to run.
Yeah, I'm going to head out.
Okay. Well, thanks for taking some time.
Thanks. Good to see you.
Appreciate it.
See you around.
Now let's take a quick break before we get back to the second half of the show. Hey, this show is sponsored by CoreOS, which is celebrating its second birthday here at GopherCon in Denver, Colorado. So I just want to thank them for sponsoring the new Stack. You can find them at CoreOS.com. Now let's get back to the show.
So Alex, I was going to ask you some questions about. I'm really interested in this whole idea of the lightweight OS, and I'm trying to. One of the things that we're doing at the new Stack is we're comparing the lightweight OSs and their different, and how big the actual OS is, ranging from some of the bigger ones at 220 megabytes for the OS down to very very small OSs like Ranchers, which is basically just the kernel and Docker on together. So I'm curious on what you think of the spectrum of the lightweight OSs right now, and what's your take on that market, and why are there so many lightweight OSs emerging?
Yeah, I mean, as an entrepreneur, our hope is to change the world, and in our weird little way, CoreOS changed the world because now lightweight OSs aren't as novel as it was when we first put it out there.
I remember first talking, I'm tell me to understand this again.
Right. Yeah, I think, so the lightweight OS thing, there's just a number of benefits for trimming everything down, and nobody's gone and refactored the OS in a while.
Why?
Why
hasn't it been refactored
just
till now?
I think it's not trivial to build a new Linux distribution, and the ones that are there, they're kind of clunky, but they work, and and so on. And I think, like Mitchell had mentioned, you need to have like a step function in difference to do anything meaningful. And so for us, we're like, let's build. It's been long enough that like a new distro could exist, and like people might want some change in the way it's doing. But let's also kind of like change things up a little bit. Let's change how like the updates are done. Let's change let's flip it on its head, the responsibilities of the Linux distro maintainers versus what the users are responsible for in terms of packaging. Let's go nuts on security. Let's just turn on all the security features that we can that in 2015 are out there but aren't being 100% utilized, or not even being utilized that well, and all those things. And so I think it's in the same way that like Docker kind of unlock something around containers, that what they hit on is struck a nerve of like companies fed up with the way things are being consistently done and just looking for something distinctly different enough to go and try to move to. And so I see the lightweight OS thing as sort of part of that. Like, yeah, the distros have been out there for a while, they're working well enough, but everybody's felt enough pain with how they're currently like built and ran and managed that like anything that looks sufficiently different is worth giving a shot. So I think the combination of this shift in thinking about how infrastructure should be ran, opened this, the opportunity around, let's rethink the OS, let's rethink networking, let's rethink kind of everything.
That's what's happening.
Yeah, and that's what's happening in the OS is part of the story. And our name is CoreOS because that was the first one we started working on.
So there seems to be some corollary to what you were talking about earlier, and just more companies writing software, isn't it? I mean, there's like if more companies are hiring people to write software, they're going to be actually a lot more active with with their infrastructure itself. Is there a corollary there at all?
So writing software more actively, what with their infrastructure?
Well, they're more. I would expect that if you have more developers on staff, right, and writing more software, there's like this deeper connection to the ops team, right? Like and we're seeing this all the time, right?
Yeah.
Where like historically you would throw things over the fence to the ops team, and then they'd say, okay, well, it's going to take a month, right, for us to get this ready for you. But now it's just like you just throw it over, and you don't even throw it over, right? It just gets updated, automatically.
Right.
And I'm trying to understand if there's a corollary there with, the need for a lightweight OS.
Yeah, I mean, so as we've designed CoreOS, and I think we're distinctly different than most of the other lightweight OSs, even though we're kind of in a shared category, we've designed it specifically for people that don't want to care about the OS anymore. So our whole point is like that you don't need to worry about updating it. You don't need to like worry about what's on it. Like just forget about it and worry about your application. And I think the change that's happening overall is the way that like companies kind of set up their infrastructure teams versus their development teams. When you go into, again, a shop like Google, there'll be the infrastructure team that is responsible for the cluster, and that's just exposed via a set of APIs to the ops people that are responsible for deploying the applications on top of that infrastructure. And there's kind of two classes of operations people. There's the people running clusters, and then there's the people running the specific applications that are being built, like Gmail or whatever. And in that mode, the people running Gmail probably don't care about the OS too much anymore. It's like the ops guys do. And then on the ops guys side, well, why do you care about the OS at all? Well, you might have some things, but we just believe at the end of the day you won't. And so it's like this model. I guess the argument I'm trying to make is this kind of change in model about the roles and responsibilities of operations. Once you have this kind of distributed deployment model changes, and part of what changes is kind of the need for an OS doesn't go away, but like the level that you really care about what's going on in the kernel and so on does go lower and lower away. You don't care about it as much. And it's weird to say like I have a product that you shouldn't care about, but you still need it. Just let us care about it for you.
You don't
let us care about it for you.
You don't need to care that it's there.
Right, exactly. And we can do it for
there.
everybody on the internet, not just your one ops team do it for your one use case, and we can solve it kind of once and for all.
So tell us about Tectonic. I mean, we've written about it a little bit. Can you explain what Tectonic is and the philosophy behind it?
Sure. So Tectonic is this Google's infrastructure for everyone else platform. All the open source pieces that we've built have been to allow companies to build their own Tectonic effectively. Internally, they're building out their own container platform of some sort and piecing together all these open source things. We took all the open source things and pieced it together into the ideal platform, and then give you the boring stuff, installers, updaters, control panels, that kind of stuff too, on top of it. So you're just ready to go. It's like we're productizing the operational model. Here is the way of running infrastructure, the way that it's going to happen, and you can go and piece together the open source if you want to figure it out yourself, or you can just have it today and we'll take care of it for you. And we've honest to goodness picked all the best components for you already. So just you don't have to worry about it. And we think that there's some value there, and that's what Tectonic is. It's this style of running infrastructure. It's heavily based on Kubernetes, which is
tell us about that.
So Kubernetes is Google's internal cluster management team building an open source version of what they did, and it's not taking what they were running and open sourcing it, but it's using all the learnings over the years and kind of doing a clean room version of that, written in Go. And it's, when we say Google's infrastructure for everyone else, it's brought to you by Google with Kubernetes, and then CoreOS. The pieces we bring are all the other components required to get it set up. So networking, the Linux OS. The distributed data stores that hold all state of the cluster and so on. Those are all the pieces that we've built. Authentication, all these things are pieces that we built, and that combined with Google's Kubernetes piece, now you have a complete package that you can go and run. Mm-hmm. So any of our components or Kubernetes on their own don't quite work. In fact, in the case of Kubernetes and etcd, which is one of our pieces, Kubernetes has a hard dependency on etcd. It won't work without it. It's an integrated dependency. It's very natural. We want to help companies run an infrastructure in this way. Google has Kubernetes. We have pieces that are dependent, or Kubernetes is dependent on, and so it's a kind of this match made in heaven for us. So it's Google's infrastructure for everyone else, brought to you by CoreOS and Google.
etcd has had some interesting, progressions over the past several months. I think in particular about the Intel's. Yeah. Can you tell us about that? How Intel's work, how you're working with Intel?
Sure. So, what Intel did with etcd was use some of their technology that essentially, Intel, being Intel and hardware, can do some nifty things. And one of the features that they have that's pretty neat, that's used by a lot of software RAID, hardware RAID vendors, is this. When you have something in memory and that you lose complete power, they can use the batteries on the motherboard to give you one last chance at saving the memory even before the power's been plugged. And we can use that to back etcd, so you can have super high performance, full in memory usage of etcd, but also in the case of catastrophic failure, it will do the right thing to shut down. Now etcd can handle the not right shutdown mode too. It was with degraded performance, and so if we're able to kind of go full in on it and take advantage of this Intel piece, as well as to the end user, they don't really know any difference except they get a huge performance win. Then it's kind of a nice little partnership.
What's the technology behind etcd that Intel looked at?
It was how the storage of the actual data in etcd, how it's backed, and you back it by
and
Intel's.
As I recall, what they learned that that there could be these failures at times when you started increasing the number of nodes,
right?
And these memory buffers, so to speak, were able to help mitigate that.
Yeah, essentially by making the data access much faster, you could scale it farther. When everything's slow, you just can't scale it as fast. Now, slow is relative. When they were talking about it, they said they natively were doing 5,000 transactions per second. And I'm like, that's pretty good, guys. Good work doing that. Yeah, they doubled it to 10,000 transactions a second. But I'm still like, hey, go team, getting it to 5,000 transactions a second. On a distributed, highly available data store. Yeah, exactly. That's pretty solid. It wasn't like we were 5. It was pretty solid already. But it's interesting. in a lot of ways, we're doing full stack things because we have the OS as well, and because we have a modern Linux distro, we can take advantage of things that other people just aren't really using yet. And so the partnership with Intel is interesting because they're shipping new hardware all the time, but because the model of the existing distros means that it takes years for them to pick up any of the new hardware features. It's everybody's incentivized when it's CoreOS and Intel to work together because they want to get their new features out there to differentiate, and we want to let our users do new things that they couldn't do before to differentiate, and users want the latest hotness in like a painless way, and so if we can do all that, it's a good win. And just the existing distros can't really do that easily, and so this is an example of a piece of technology that we could, it's actually been around for a while, but we can flip on in hardware and take advantage of relatively quickly.
There's other things you can take advantage of too. I was actually talking with Redbeard about, for instance, the need for a load balancer, right?
Sure.
Things like that, which you would think would be, a require, which makes sense because there's companies like Amazon which have their load balancer, right? But if there was a load balancer, you guys would integrate with, that would provide the ability not to have to do it on top of the Amazon layer. And that seemed interesting to me, kind of like how that it speaks to what you were saying about the OS being at the very core of things.
An example of it was not necessarily Intel, but this new kernel feature went in around networking that was very applicable to container networking, and it gives you high performance networking that's perfectly suited for a container, and it lands in the upstream kernel, and we can just roll that out to all our users pretty quickly and flip it on for everybody. And that process is, from commit going in to being on the stable branch in the kernel and rolling out to users, maybe like a month or so, where previously that's like, that's years, like 5 years later, the feature ends up on a company's box, and it's a pretty radical change in the ability to deliver software down to even the OS level.
So going back to the start of the conversation, how does Go make that process?
Sure. So in the case of Go, in that part of the stack, the Go is actually used on the other end, how the updates are served. So the way we are able to safely give people updates is by they put the model on how updates are delivered. It's this alpha beta stable kind of model. We have lots of users on the alpha channel that want the latest and greatest, but are okay with some volatility in their environment. So essentially we have a big public QA test lab running out there of all the alpha users. And the web server that's managing, kind of distributing of all those over-the-air updates is all written in Go. So that's one example. Inside of CoreOS itself, there's some pieces that, for instance, when you're doing a rolling upgrade across an environment, you don't want to take down all machines at once. You want to kind of to roll it out. And so having a service that can coordinate that in your environment so that only one machine goes down at a time, all that stuff's written in Go. That's a tool called Locksmith, backed by etcd, another Go project. So all these pieces, all the kind of new enabling features that we have are all because of Go.
So with Kubernetes, that's a pretty tight integration there that you guys have with them, isn't it? Tell us about that. How Tectonic integrates with Kubernetes.
Sure. So Kubernetes is part of Tectonic, and the end user APIs and everything that you are interacting with when you interact with Tectonic are the Kubernetes APIs. So it's sort of it's the cluster management. It's a low-level system, but Kubernetes is the top of that system. So it's like the highest level part of our low-level system. Okay, like CoreOS Linux itself is, for instance, below Kubernetes in terms of the stack. It's like really low level, right? And so by signing up for Tectonic, you get a commercial distribution of Kubernetes bundled in there. It's all supported, and versions are all mixed and matched right together and everything, and so on. And in these distributed systems, that's kind of it's a non-trivial affair to get all the right pieces in there. So Kubernetes is a pretty anchor piece of Tectonic. I mean, in a lot of ways, you could say it's a commercial distro of Kubernetes, and then all the stuff related to it.
Now it runs. Do Rocket containers work with that then?
Yeah, so Kubernetes supports Rocket.
Tell us about Rocket for people who may not know.
Sure. So Rocket is a container runtime that we are building and built. We put it out about 6 months ago, maybe 7 months ago now, primarily to address some issues around security and the process model that we couldn't get fixed in upstream Docker, and we just felt there was a better way to do it. And for Docker to do it, essentially they'd have to rewrite Docker, and it's not going to happen anytime soon. So we went down that path, and it's been working pretty well. To the end user, whether we're using Rocket or Docker to run your container, hopefully you don't care and you don't notice. Inside of Tectonic, there's both are used. Both Docker and Rocket are used. Tectonic will always be Docker compatible, so if you build your Docker image, you can run it in Kubernetes, and that's no problem. We will never break that compatibility. And with the Open Container Project thing that we recently announced with Docker, as well as the rest of the ecosystem, that image format is now a vendor neutral thing owned by the Linux Foundation that's based on some of the Docker code.
That image format.
That image format, exactly. So when I just said Tectonic will be and stay Docker compatible, that over time will be open container compatible. And as an end user, you just need to worry, does the application have open container support? Then I can use it, and you don't have to worry about if it's Docker or Rocket or whatever. It's just like I use open container and it works in all these different things.
So tell us about Open Container Project. What's next?
Yeah, so the goal is pretty simple. We want our users to package their application once, so they can use Docker build, or they can use some other tools or whatever to make their container, and then they can run it in a variety of environments in a consistent way. So if a user wants to run it in Docker, they want to run it in Rocket, or if they want to run it in Amazon ECS, or if they want to run it in Google's Cloud or VMware or whatever, they have their one artifact that they can take and then go and run in all these different systems. And it's kind of the promise of the standard shipping container, is like you have this one unit and a bunch of different systems can go and handle them, in a vendor kind of, let vendors compete, but the standard doesn't really change, so everything is interoperable. And so the goal of the Open Container Project is exactly that. It's essentially what we set out to do as part of the Rocket piece. The only difference is now Docker is at the table as well, and that's the bright thing for the users, is that they only have one standard that they need to worry about.
What are some of the technical additions that will be made to it over the next 3 to 6 months?
I think a lot of it will borrow from the AppC stuff over time here. So some of the basics are like just how do you do cryptography and signing. I mean, these are kind of really basic things that haven't been addressed yet. And so that's all just coming together right now as we see it. The point is to keep it minimal and scoped as low as we can, but you still have to have a certain baseline of usefulness. And so the things we care about are security and crypto and making sure all that stuff is done really well. And we'll definitely contribute that and make sure that the spec kind of represents all of that stuff. There's a point where it's just kind of done. Like again, using the shipping container metaphor, it's like at some point the dimensions and like how much weight it should be able to carry, and it's just kind of like fixed.
Let's move on.
Right, exactly. It's Ben Golub, the CEO of Docker, said it best. He's like, let's not debate on the width of the railroad tracks anymore. Let's just like get that sorted out, and then we can all go build our trains however we want it to work.
Right, okay. Pretty standard. Well, Alex, I think we've covered a good bit of ground here.
Yeah, we have. We have, Alex.
So thanks for taking the time to talk. Good to see you.
Good to see you, too.
And good luck with CoreOS and everything else. And let's enjoy GopherCon. And your birthday party. You're having a birthday party tomorrow.
That's tomorrow night.
Great. All right,
thank you.
Thank you.
That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor, CoreOS, the first influential micro-operating system in the market. And they have had quite a run over the past 2 years. They're a major player in the container ecosystem. Happy birthday, CoreOS, which is celebrating its second birthday this week at GopherCon in Denver, Colorado. Woo! And they are the sponsor for this episode of the New Stack Analysts. You should check them out at CoreOS.com. Happy birthday, CoreOS. Audio editing and sound design for the new Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.